Station, this is KRLA Radio. How do you hear me?
KRL Radio, we hear you loud and clear.
Well, it's good to talk with you from back on Earth. What's it like up there? We see images. To me, it always looks like weightlessness is in slow motion. Is there anything to that? Describe what it feels like to be in weightlessness.
Weightlessness, it's the opposite of being heavy, and it's hard to describe. It's wonderful. It's uplifting. You can float around the room as Andre is doing here, and we move slow because if you move fast, you can easily get things out of control. And just for example, I've got a little drink bag here, and if I give it a fast push, it just disappears. It's already in node 2 now, and you don't want to push things fast like that because you'll lose them. They'll bang around on the walls. Maybe they'll knock something else loose. So one of the things that you rapidly learn when you come into space is that slow actually gets things done quicker than fast.
What impacts does the weightlessness have on normal body functions? When you drink liquid and it goes down into our stomach, is there any sensation of it not feeling settled?
Well, actually, you can try something yourself. You can stand on your head and you can still drink because the body takes care of it. It's pushed down to your stomach. So in that sense, we can eat and drink what we want. The control of fluids and food in your mouth is also very good with your tongue. So there's no issue there. So from eating and drinking point of view, it's pretty normal. But you have to be careful with the food, of course, that things don't escape because that might make things a bit dirty and things like that. But that is a thing we have to get adjusted to deal with floating fluids, with floating food during dinner.
What about the sense of movement or speed? I'm told you're moving at like 17,000 miles an hour up there, a couple hundred miles up. But yet you're so far off the Earth. Is there no real sense or feeling of movement?
Well, that's correct. You can compare it actually with a flight in an airliner at about 10 kilometers at altitude, because the angular speed is the same. So the speed of the Earth passing by from a plane is the same as for us at 400 kilometers altitude. So you see that we're moving, but you don't really have the feeling of enormous speed, like you don't have in a plane as well.
Is there any sound at all up there, or is it just the fans and things that run? What's it like inside the space station?
It's kind of like living in the engine room of a ship. We're surrounded by machinery. Space is a place where human beings cannot innately live, and the only reason we can live here is by taking machines with us to provide all the functions. And one of the things that we need to have is air movement, because there's no gravitational driven convection. There's no wind up here, and things could get pretty stale pretty quickly. And so we always have fans blowing and moving air around, and that adds a certain level of background noise. And then we have mechanisms like our treadmill and our stationary bicycle and other pumps and equipment from both systems and scientific viewpoint. And all these things make mechanized machine kind of noises. And when you add it all together, it's a reminder that you are living in a machine, and the purpose of this machine is to allow you to be here.
You have a commercial supply ship coming for the first time up there. What is the importance of that?
The importance of the Dragon vehicle coming up is letting some entity other than the government do the supplies for the space station, for moving off into space. So now the governments, like government-run agencies like NASA, can concentrate on the frontier aspect of being in space. They can define the mission, they can define where we're going and what we're going to be doing, and then we can have the commercial entities supply us the goods and services that we need in order to do the mission. And I like to use the analogy of forts in the Old West in the United States. And the wagon trades that supplied the forts were run by commercial entities and later replaced by the train system, but the government defined what the mission was and ran the forts. And I think we're going to see that scenario play itself over and over again as humanity moves out into space.
A little bit now about the risks up there, space debris. Sometimes we'll see stories about things that are done to protect against that. There's a lot of junk floating up there, or do you ever see anything fly by, or would that be tough to see?
There is a lot of junk. If you look at the radar targets that where they plot them as little dots around Earth, and it's like, wow, we're flying in a cloud of junk. However, space in low Earth orbit is a big place, and the chances of actually running into one is pretty small. However, we do have to watch out for these SAIDs, and every once in a while we do a debris avoidance maneuver, which is a NASA acronym for DAM. So we can actually say DAM on the loops now, and in the context of debris, you will be understood. And we've done a couple of dams since we've been here, and one time we did not have enough warning to do a dam, so we went into our Soyuz as a safe haven in case of collision, but there was not one, and so we popped out of our Soyuz and went back to work.
And then what about these solar flares that we've been seeing from time to time in the news? Is there any extra radiation on you guys, and is there anything you do to protect yourselves?
There's probably some extra radiation. However, we're exoatmospheric, but we're still protected by Earth's magnetosphere. Earth is like a great big spherical magnet with a north and a south pole, and the magnetic field radiates way out into space for thousands of miles, and it intercepts these solar-generated particles and deflects them. It's kind of like Scotty turning up the shields for the Starship Enterprise, and Earth does this naturally for us, and so we don't have to worry from a radiation safety point of view when most of these solar events occur. And the biggest effect of these is that it makes beautiful aurora, and we like to stick our noses against the window in the cupola and look at these spectacular aurora displays that happen every time the sun goes burp.
Lastly, read an article about how the eyeball changes a bit for those who've gone in space. Do you sense any changes physically when you're up there in weightlessness?
Well, there's a lot of things happening with the human body and weightlessness because, of course, it functions best at 1 times gravity 1g, and the body adapts to the microgravity environment. Some things, however, like bone loss and muscle atrophy, these are things that continue on the long run, and we have to do things against that. Now there is indeed some new indications that things happen with the eyeball, and that this investigation is going on at the moment. I mean, we have been going to space for long durations for many years, many decades, and so it's not that serious that we cannot go anymore. It's just something new that's being investigated, and see if this is something that we have to find countermeasures against or something else. So at the moment, it's not an issue that we are very worried about.
Well, it's been good talking with both of you. Thank you very much.
It's our pleasure, and come back and visit us again.
We'll do that. Thank you so much.